Hey everyone, welcome back to part 2 of lesson 1, implementation of networks, and this is the practical section. So what we covered last time was an overview and a lot of the theory of networking for this lesson, and it provided a good fundamentals for what we're going to be moving on to. So we covered introduction to OSI, IP addressing, MAC addressing, subnet masking, and VLSM, and then using all that, breaking it down into a more practical method for upon network diagram, which we talked about the tools we're going to be using for the practical element. So I'm going to be using a lot of Cisco Packet Tracer during this demonstration. Other options, as I said, was GNS3 and Wireshark for seeing what traffic is going on. But also one thing I didn't mention last time was Boson is another networking emulator which I have used. Quite good for questions in different topics, especially like CH and CISP. But one of the things that I find it good and bad is everything's got its advantages. It seems to support more than Cisco Packet Tracer with regards to technologies, but it doesn't flow as easy. So this is the good bit. Let's get practical. I said last time we're going to be working off of a network diagram that looks a little bit like this. With the 3 hosts, 2 switches and a router, and then a switch and a router within each LAN, and a serial port that connects the 2. We're going to be configuring the LAN section on Cisco Packet Tracer. So our diagram is going to be looking like this. And then as you always move on, and what I've done is then use this build to sort of plan out a network diagram itself. So on the right hand side we've got the 192.168, hold on, here we go. So on this side we've got the 192.168.100.0/24 network. So this is the corporate network on this side, and our LAN that we're going to be configuring is on the left. This corporate side is already configured for us, and also I'll be supplying the Packet Tracer files along with this lecture so you can have a play yourself. And I'm also going to be taking it a bit of a step further on this build, but for now I'm going to be looking at the LAN section of the 192.168.1.0/24. So I've allocated that IP address range out, with the clients being .1, 2 and 3, this switch being 200, and my default gateway being .254, so the last usable host. The WAN link here is 22.22.22.0/30, so it's that point-to-point network, and yeah, so we're going to be using that quite effectively. We're going to be going through the entire configuration scale really. So let's move on. Looking a bit closer at what we're going to be configuring, you can see our IP addresses there for the client, 192.168.1.1, .2.3 for the 3 clients. They're all /24, so subnet mask of 255.255.255.0. We've got they're going to have all the same default gateway, which is going to be the gig 0/0 on the router up here. So at this point here, we're going to be configuring the IP address of 192.168. Oh, I've missed that one off. So we're going to be configuring 192.168.1.254 on that. On the switch VLAN 1, which we're going to be covering that off, it's going to be 1.200/24. So the full LAN is going to be using the same default gateways and setup for there, and then also we're going to be using that WAN link, and we've got to also tell how our traffic's going to get out of there. So we're going to be doing a little bit of routing as well in many different ways. So we've got static route protocols, we've got dynamic, and we've got default route, which we'll be configuring all 3 just as part of this build, and also expanding this build slightly to incorporate other layer 3 technologies such as first hop redundancy protocol. So let's get a bit more into it. I'm going to quickly show you how to configure an IP address on a PC, both Windows and Linux quickly. Then I'm going to show you how to configure an IP address on a switch and a router. The interesting bit for the switch is it's not a physical IP address, you're not putting it on an interface. we're going to be putting on what's known as a switch virtual interface, which is an SVI or a VLAN IP address really. So we'll get onto that now. Cool. So as I said, I'll show you how to configure an IP address on a Windows machine. I know most of it has done this before, but it provides a very, hopefully, quick refresher. If not, a new introduction, which I hope it's not. This is quite a common window with regards to setting IP addresses. And you can see there, I've gone for 192.168.200.1. This is just a virtual throwaway machine really that I've built. I've clicked down into the subnet mask and it's automatically done a Class C subnet mask for us, which is at /24. We don't necessarily need to set a default gateway for a very simple network build, but for this time I'm going to. Cool. You don't always need to have a DNS IP address either. You can have DNS can sit internally or externally from your network, but as long as we've got that configured, we can press OK and OK, and it might take a little minute to sit on Ethernet 1, and then we can always go in and check what its IP address is. So we've got Ifconfig to check its IP address. This might take a little second. I've got a few different things running. So 192.168.200.1, so it's taking an IP address. We can also do Ifconfig all, and then which tells us a little bit more really. So it tells us we haven't got a DNS IP address. It tells us our physical address as well. And obviously, just so you know, to the left, these commands aren't just for me; they're also for you. So I'm going to be supplying all of these commands at the end of the lesson in a text document. There's currently over there's 400 lines of commands that I saw earlier when I was typing these up over the last sort of week or so. So it's a bit of a freebie really. But the key thing is to understand the concepts as well as the commands as well as verification. So whenever you set something up, you've got to understand what's going on, what you're setting up, the commands to set it up, and also how to check. So we just set up the IP address. We understand the theory of IP addressing, and also now we know how to check it. So using Ifconfig to check, or Ifconfig all. I know I'm going to be covering a few more bits next week with regards to this, so you can see our IP address there. I'm just going to throw a few extra little commands just into Windows so you can have a play on your own laptops. So we've got root print. This is something that don't often use too often, but you can add this. This is something that Windows can add to itself when it discovers a new network and will get traffic there. It's trying to copy a little bit of what Cisco does in its proprietary networking, but not as well. But you can add in static links to this and static routes and to direct traffic how to get there in its default networks. So you can see what networks it's seeing. We've got ARP --A, so we can see what addresses we've got here. So we've got the virtual interface that I had before, and we've also got other networks. We've got netstat, and I don't expect a lot to be happening on there at the minute because netstat shows you sort of that layer 5 information, that session layer. An extended version of this is -NAOB, so that links up into that requires first of all to be on as administrator because I'm looking at processes then. So those are really a few of the commands that you can run yourself on your own laptop. This is I'm just on as a very basic user at the minute. So if you want to run them, you're more than welcome to. I'm going to quickly show you how to set IP addresses quickly on an Ubuntu machine. So providing I can get into it. There we go. Cool. So setting an IP address on an Ubuntu or Linux machine is obviously, as soon as you talk about Linux in Ubuntu, you talk about command line, and this is just a quick introduction. I know we're doing more on Linux and more on Ubuntu in 2 weeks' time or 3. So quick check of the IP address there. We can have a few IP addresses on this interface. It's down as ENS 33 on this one at the moment. it's just a case of this is a virtual interface. A lot of the time it's down as Ethernet 1 or Ethernet 0, ETH0. So whatever you commands we put in relating to whatever the interfaces are. A lot of people might be watching and going, what about Ifconfig? It's an older way of doing things and often doesn't come as standard installed into various versions of Linux now. You can install it if you want to stick with your old school methods. Even I had to get onto the IP address root, and that's what it's short for. IPA is short for IP address. It's the new way of commands, really. Just to get into setting an IP address on the fly, really, adding that in. So going back to the Windows machine, just so we can prove our setup is working. I'm just going to ping, so Ifconfig, make sure we're in the same network, so ping 192.168.200.2, and TAC-T extends that and doesn't stop being interrupted. So at the minute destination host unreachable, that's going through ARP requests and requesting this MAC address so it can continue that ping. I'm just going to go back to your Ubuntu machine, set this IP address up. So using this IPA, don't want to get too bogged down with Linux stuff at the minute, but if I do IP address and then help, because that's one of the assistants, you can just scroll up and see this bit here. So Linux and a lot of operating systems as well as Windows has got these help options, so we can see what we're typing in. So if I'm just to think about that command now, I'm going to add the IP address in to the interface. What I'm going to do is IP address, add IF address, so that's going to be my IP address, dev, then the interface name, which we know is ENS33 because we've already ran IPA. I can say for how long as well. So what I'll do is I'll just add that in. IPA, or IP address, add, and then it was there 192.168.200.2. And luckily, for Linux, we can add in the slash notation or the cider, the classes into domain routing, and 24 dev ENS33 for the interface. So that's comes saying operation is not permitted. I'm currently logging on as a user called demo, just for this demo purposes. So what we need to do is add in sudo, type in the demo password, and then that should have applied. IPA, you can see here, one of many IP addresses I've added, .2, and then let's quickly go back onto the Windows machine, and that ping's now dropped in. Happy days. So that's proven our ping's working either way, and internally within these virtual machines, our network's connected. So I'm quite happy with that. I'm just going to get rid of these virtual machines, and then we're going to move on to real networking now and sort of our build into Packet Tracer. So what we've done there is configured the IP address on a PC, so a virtual machine. We've done that on both Linux and Windows 10. Next, we'll go into configuring IP addresses on switching router. So happy days. That'll be a part of the next section, which will be introduction to Cisco OSI, because I want to get into the Cisco OSI, the iOS, the interactive operating system. Show you the modes of base config, which will involve configuring IP addressing, and then we'll go and do some very basic show and verification commands, because that's really important whenever you configure something. You have to prove it's worked. So I'll quickly jump on Packet Tracer now. We'll show you how to do that. So this is our network build that on Packet Tracer, which we're going to be using through this lesson. It's the build that we had a quick look over on the PowerPoint earlier, and that we drew out, and that we sort of had a look at the IP addressing. The right hand side, so the corporate network with the two servers, the switch and the router, is already configured for us. So we just need to configure the LAN side. So we need to configure the switch and the router, whereas the PCs are already configured with the 192.168.1.1, 2, and 3 with their default gateway. So as soon as this network is set up and the routing is in place, the clients will be able to contact their respective servers, whether it's the domain controller or the web server. So using the commands on the left, what I'll do is I'll demonstrate and talk through each of these one at a time with relation to starting with the modes and escaping and how we use that sort of Cisco's operating system and some of the assistance that we've got. And as again said again, these notes that I've got on the left, I will be supplying with this video, and so that you can take it away and learn and use them for yourself. Great. So first of all, let's start on the switch itself. So it's blank, and this is the first sort of step into the Cisco IOS. What we notice with this build is, before I carry on too far, is you can see the green lights that are connected to the switch. So as a switch naturally comes unlocked, whereas a router, you can see anything, all the cables to that are actually red, so there's no data flow there. The router, because it's a security device on top, naturally comes closed, so even turning it on out of the box requires configuration, whereas a Cisco router is basically a very smart hub, and the way it passes its data, but without any configuration, it still works intelligently and does minimize traffic, because as I said, each port on a switch is its own collision domain, so it still minimizes traffic and still limits the availability to sniff traffic using like a Wireshark, for example. But that's sort of out and out really, but I just wanted to describe why the red lights were on the router and there were more green lights on the switch. But between the gig 0/1 and the gig 00 for the router, on the left hand side on the LAN router, the reason why that's red is because the port on the router is currently closed, or shut is one of the key words. So what we're going to do is get the switch configured. So what we should notice is some configuration coming in place, and then be able to ping that from the clients. So we won't be able to ping our default gateways yet on the clients, but we should be able to ping each other. So just as an interim little test, what I'll do is I will try and ping the between the clients. So this Cisco packet tracer is quite intuitive. Ifconfig, Ipconfig. I'm thinking back to Linux, and not even modern day Linux, like old school Linux. So I can see 192.168.1.1 then. So I'm going to ping between the clients just to prove that the switch is actually working out of the box. 192.168.1.2. So I can see there it's pinging. Lots of things going on there. We can identify TTL 128 as Windows as well. So and time to live hasn't decreased, so it's not going by any routers. This is just the additional information that we gain to know as we sort of develop understanding of pings and also networking as a whole. So if for example a ping or a bit of traffic goes via a network, the TTL will reduce by 1, whereas the TTL is basically loop prevention, but also to stop traffic exuderating that time to live, and as part of cyber really is to identify and footprint different operating systems. So some key information there. So config. Just going to see if I can ping my own default gateway. Ping 192.168.1.254, which is the router, and I shouldn't be able to at the minute because of effectively there's no link to it through that switch, as we saw it with red. I'm not sure how far and the limits we can push this virtual client on Cisco Packet Tracer, but no, that's actually quite intuitive. So it's picked up the MAC address for client 2, client 3 responding, and then -A, -A, and it's picked up and it's learned dynamically the MAC address for client 3 as well, and vice versa. So because they've come in, they would have learned each other's MAC addresses. So desktop command prompt. So because one's contacted 2, that means 2 now knows the MAC address of 1, which is good. Cool. Right, back to the switch. So we've proven communications between these and up and down. So we've got ingress and egress traffic out of fast Ethernet 0/1, 0/2, and 0/3. Just going to quickly describe what that first 0 means, just for your own knowledge. So with Cisco devices, if I had real ones, and what I used to teach was within a classroom of 8 switches and routers stacked up high, you can use something called a stackwise cable and prong them together. So instead of having a 24-port switch, for example, which you should be able to see on the front here, physical. So instead of having a 24-port switch here and 2 gigabit ports, you can stackwise them. So you can have a 48-port fast Ethernet switch, and you can manage using the single command line on one of them will manage both. So you can have that first 0 will be this switch, and then if there's a duplicate underneath, that will be fast Ethernet. So this port here is fast Ethernet 0/1/2/3/4/5/6. If there's a switch below here, that switch would be this switch and this port here would be fast Ethernet 0/1, fast Ethernet 1/1. So it's that first 0 just substitutes the where it is in that stackwise relationship. Cool. Is there anything else? I don't think so. Cool. Just describe the switch's virtual interface, for example. So before we go configuring it, and you can see from when I'm within my base config, this is where it sits configuring the switch's virtual interface. We only apply a interface on this switch for 2 reasons really. A, to test communications to it, and also to remotely manage it. So once we've got the IP address on, we can say that we can ping it, then we can communicate into it using either Telnet or SSH, which is the more secure way. So those are the only 2 reasons we really put an IP address on for a layer 2 switch. When we talk a little bit more step forward, particularly not in this course, but more within a sort of CCNA qualification level or within greater networking, when you talk about layer 3 switching, which is effectively putting up some of the technologies down from a router into this 24-port switch, breaks a network down further and makes it more effective. So we'll use some of the technologies we're going to be talking about later in routing, but brings them to this switch. So it brings in more IP capability instead of sort of playing with MAC addresses and learning MAC addresses and on layer 2 technology, which this switch will be playing. So we'll get on to configuring and working with the Cisco IOS a little bit more. So with regards to CLI, we can see the prompt here, and we can see the less than sign, I think. So that indicates what mode we're in. So talking about modes, I've got them described here. So the first mode we're in is user mode. We can't really do anything here. So what we have to do is elevate our privileges to work through. It's sort of like saying between user and an administrator. So we're not quite an administrator yet, but also there's no passwords. This is a blank switch. But when we set passwords, we need to know the passwords to get the right accesses, and that's what we're going to be setting up as part of the base config. So working our way through the commands. Enable is EN is short for enable. I can hit tab to complete the rest. So if there's no other commands with EN and we hit tab, it will complete it for us. So we can type EN or enable. I often type EN, and you can see the prompt has moved to a hash. So that now tells us we're in privileged user mode. So that we can do within privileged user mode, I'm just gonna add in here, without my spelling, obviously I'll make sure my is corrected. We do our show commands here. So we look at the state of things within privileged user mode. So we often come back to this to show things, to verify anything that we're configuring. So one of my favourite show commands is show IP interface brief, which also shortens down significantly to show IP int BR. So we can see here our setup of, as I said before, fast Ethernet 0/1 to 0/24, and also 2 gigabit ports. So that's generally what we'll use as our backbone between switches and routers. And we've also got a VLAN 1 interface, which is our switch virtual interface, which we'll be putting an IP address on in a few moments. We'll go back to the modes a little bit more. So we've gone enable into the privileged user mode. If I do conft, which is short for configure terminal, so you can either type configure terminal or type conf space T for configure terminal. That brings us into global configuration mode. So that's basically the administrator level of permissions. So we're configuring things, and whatever we configure to the whole device. So that's what's called global. And the next sort of level we go into then is sub-interface mode. So whatever we configure at that point, we're only configuring that sub-section. So if I go into an interface, for example, interface fast Ethernet 0/1, we're now only configuring that sub-interface. So whatever we do, whatever we changes, so we can shut it, for example. So we've shut down that interface. We've only affects that one interface and doesn't affect the rest. So the rest of the fast Ethernet ports you've just seen should remain open. So a few of the little commands I want to show you is, so we've gone through these. I'm going to show you this in a minute, the exit command, and I'll show you Control-C, and it is really, really good. I've shown you tab briefly, which completes our commands. I want to show you this do command. So if I want to run a show command, but I'm in a different mode, and we're going to be running this throughout, so that's why I'm sort of briefing you early on it, is so I can do show IP and brief, which is my favourite show command, but run it from a different level. So I normally would run your show command in privileged user mode, but now I'm going to be running it in global configuration mode, or actually sub-interface mode really. So if I do show IP int brief, I can see there, I can see my fast Ethernet is shut down, which is good. I can see what I'm doing is verifying. I can actually see, we'll be talking about this show command a little bit more later, but I can also see the fast Ethernet 2 and 3 are up. So that means I've just cut off comms to client 1, the first host. So that should appear red. So I can see red there and red. Yeah, so not great, but we're actually interacting with this network now, which is really good. So my VLAN 1 is administratively down. The reason why it brings in the word administratively is that that's something that's been interacted with and manually configured. So do is good, but do is not amazing. So where I can go in privileged user mode, I can tab for show and find out whatever show commands are available. There's no tab available for do, so you need to know the command. So if I do show for show, I can't tab that, whereas I know the BR should be brief, and I can't tab it, it won't complete it for me. So you need to know the show commands or whatever commands you're typing in for that do. So if I want to go back a few modes, I'll start from the beginning and work my way up again, just to be familiar again. Exit, and I'll type exit again. So we're going from sub-interface mode to global configuration mode, then to privileged user mode. So I'll just show tab IP int tab brief. So tab is really good command, and also we've got question mark. So as a big assistance, really, we've got question mark. So what that does is either show us anything after a certain point as a wildcard, as a single character, or every command available to us at the time. So if I do show question mark, this shows us every show command available to us. So some of the technologies we're going to be touching on, we can use show access lists, or show CDP, Cisco Discovery Protocol, show DHCP, show Etherchannel, we'll be doing that as well. show interface, show LLDP, link local discovery protocol. So that's alternate. Right. Anyway, so we can. Those are all the show commands available to us. This is sort of a crash course in CCNA, I suppose, not up to the levels of expected, but this is pretty much a good insight into what's been covered. So those are the modes. Escaping, to go up the mode, so it's enable, configure, terminal. So you can tab it if you want, but you can just conf T, and then we can type interface fast Ethernet /, and just imagine if you were typing something and you were getting stuck and you were like, oh, I'm typing a big command, I'm unhappy with the command, but I just want to escape out of it. So your emergency escape and what I sort of where you it gets you out of trouble is Control C. So if you press Control C, it brings you out of the command you're typing, but it also puts you back into privileged user mode. So then you can just verify quickly where you're at, and you can say, oh, okay, so what I did, it didn't take effect. So it doesn't enter the command, it escapes it, and then also brings you back entirely to privileged user mode. Cool. So that's a quick overview with regards to the Cisco IOS and the modes working up and down and what they do. So as we said, global configuration mode configures the whole device. DVICA, you only config sort of local portion, really, local interface. Cool. And then escaping, you've got exit to go back modes, or Control C, which I prefer. So it's literally press Control and C, not Control plus C. So it's 2 buttons, not 3. I'm not showing you to save it yet, so we've made a few changes. So show IP into brief again. You can see here, this is a result of what I was doing earlier. I've got my switch is administratively down, so my interface is administratively down 0/1. So if I want to save that, I can go copy, run, start, hit enter. Do I want to destination file name startup config? So that copies the running configuration to the startup configuration. Cool, because they're 2 different files. So whatever I'm doing, I can just reboot the router or the switch, and it's not necessarily saved until I save it. There is a very short option of that, which is WR, which is read write, or write read to read, which is the old way of doing it, but very quick and crude, I suppose. You can only do copy run start in privileged user mode. So if I try do it in global configuration mode, it doesn't work. It doesn't find the command. Whereas I wonder if we can do. Yes, we can. You wouldn't want to normally do this, but luckily this isn't a real network, and Cisco Packet Trace is quite forgiving, so we can do copy run start. Not something I would ever recommend doing, but just for sort of training purposes, we're aware of what the do command does as well. So we've worked our way through that list. Just want to show something quickly. So if I go int and then question mark without the space, it shows you what commands are available based on where that question mark is placed. So if I go I question mark, so IP or interface, so it tells you about what commands begin with that letter, providing you put the question mark next to the letter without the space. But if I do IP, then I can see IP and what subsequent commands are available. Cool. So that's the overview. Next I'm going to be moving on to the base config of the switch and getting that configured, and also try and keep it secure the best I can along the way as well. Right, before we start, I just want to reiterate something, that the commands I'm going to go through for the base config and also the rest of the technologies we're going to be covering are not exhaustive. So there's always additional technologies and always additional commands. I will try include them in the notes, and if I think of any while doing demonstration, I will add them in. There's already a few I'm already thinking of later on in the lessons. So as a part of that, we'll go on to the base config. And yet again, it's not exhaustive. There are different ways of doing it. There's a lot of Cisco guided ways of doing it and plus ways of doing it as well, and I'm trying to follow best practice along with this security at all times, and I'll talk about that, what we're doing. So let's go on. So we've got to start with the bottom up. As we've already proven pinging between the clients, we need to configure the switch to achieve the network objectives, really. So we're configuring this, even though it's already working, we're configuring it to be secure and also to pass traffic more effectively. And this is what the base config does, then into the advanced switch settings and layer 2 technologies. So I'm just going to quickly get on the switch, get on the CLI, and start configuring it. This is a near enough blank switch. There is a little bit of configuration what I've already had on. So if I enable up to privileged user mode and then show IP interface brief, you can see I've already shut down fast Ethernet 0/1. That was from the previous demo. So what I'm going to do is run through the base configuration, which, as I said, tries to align with Cisco's best practice. There are a few little bits missing, but we'll run through that and I'll describe each step as we're going along. So enable into privileged user mode, which we already are, conf-t into global configuration mode, and then the first command I'm doing is no IP domain lookup. Often tricky to tab your way through that, but what that does is stops it looking externally if you type something wrong, which, as we will see, quite often I do. And if I type something in like test, for example, often what that would do is look at a remote DNS server. So it stops that happening, really, and stops you hanging out, because it literally pauses the session for a few minutes, anything up to 2 minutes. So it's as you're getting along and you want to really crack on with your build, and it's really good to get that in there, and really good to get that in early as well. So if the infrastructure doesn't need to look up a domain service, disable it. And especially we're doing it this early on, so if I was to spell anything wrong after this point, especially hostname, then it doesn't hang me out to dry, which is good. So hostname, as we can see, I'm nearly typing things wrong already. So hostname, this is the LAN switch. So we can see our prompts changed already, and we're interacting with the running configuration, not interacting with the startup configuration just yet, because we've not saved it. So we change hostname. Next one, service password -encryption. So what that does, it turns on a level 7 or type 7 encryption on the Cisco switch that we're currently working on from this point forward. So any plain text passwords we're going to be putting in, so later we'll see we put a few passwords in, like as soon as we type the word password, and whatever password we put in, it'll encrypt that in the running config and the start config. So when we can check, we can't see any of those passwords. We'll see just encrypted. That isn't a very high level of encryption, but it's something that will prevent like over the shoulder or shoulder surfing effectively. So it's very low level, can be broken, and we'll have a little look at that after actually. So next command is enable secret password. Bad password to use, so do not use it. I could, for this simple build, I'm using password just so I know I can get back into it later. But as a part of the enable secret, I'm just going to go back and show you what the options are. Enable, and we've got two choices. Enable password, which sets the privilege level password. So when we go enable, then conf-t, it will ask us for a password. And we've also got secret, so it sets the secret password. So what actually that does, whereas with service password encryption, it sets that type 7 encryption. What this does, it hashes our enable password in MD5. So actually, it's not an encryption algorithm. It's hashing, but it's harder to break. Really, it's harder to brute force. So it's that little bit higher level. So if anyone was to get hold of our config, it would be harder to reverse, especially if you're using a higher complexity of passwords. So if I'm going to use password, as we can see on the left hand side, which is really bad drills. But if I use a far more complex one and it produces a far more complex MD5 hash, then it'll be harder to break. And often you can copy and paste these and brute force them online as well. So it's really easy to do. But if they're more complicated, then necessarily it's not going to be a part of a rainbow table, for example. So I'll just do enable secret. Actually, I'll show you both stages. So enable. Oh no. So I'm setting enable password, and then I'll show you the difference. Enable secret password, and then enable password. You have chosen the same password. Please re-enter it. Not recommended. This is just a demo. Do show run. I'm just going to quickly compare the two. So I've got Type 7 encryption on this one and MD5 hash on this one. You can see it's longer in length as well already, so it's actually going to take longer to brute force. Type 5 or MD5, and you've got 7 here, which says the type of encryption it's using. This has been encrypted because of the service password encryption with Type 7. This has been hashed with our pro word secret. So I'm just going to quickly try and see if I can break it online. So MD5 crack. Let's have a little crack station. So just bringing this in. I'm just going to paste this in and see if I'm sort of interested to unknown format, unrecognizable format. Okay, so if it was on a real Cisco device, iOS, it would generate the correct MD5 hash, but obviously this hasn't generated it because it's a software emulator. So I'm just going to quit out of that and carry on with my base config. So we've done enable secret password, which MD5. Then we do IP default gateway. And the reason why we're doing it quite early on is currently we're in global configuration mode. So whatever we do affects the whole device, and we're setting out our default gateway for this device so it can access externally to the network if necessary. Often, if you don't want your device accessible to the outside world, do not set your default gateway, but it's just an additional command. So now we're going to enter sub configuration mode or sub interface mode, and then go into the line con0, which is the console port, which is the serial port of any Cisco device. So that's what you plug in, and it's almost raw data coming out, where we, in the real world, will be using PuTTY to connect to it, and we'd select serial connection. So line con0, we've got login local. So what we're going to add in later is a username and password as a part of a more secure way. I can add a password here and say use this password for the console port if we're connecting. So this is the first password we would need. What I'm going to do, instead of saying password, I'm going to say login local. So our options are here. We can say login local. On real devices, we can also set in radius or attack server. So attack server is Cisco proprietary. It does the full SSA stack, so it logs your authorization, your activities as well. So it does it per character, which is quite advanced. So login local, we'll add in a user later in the global configuration mode, and we're going to use that username and password to connect into this. So exec -timeout 0.4. That's sort of bad drills really, because that's actually saying 0 minutes and 4 seconds. So we're going to get timed out every 4 seconds on this console port. So I'm changing that round to say 4 space 0. During a lot of demos, people put 0 space 0, which is bad security, saying do not time out. We've got logging synchronous. So logging synchronous is a usability command. So what it does is, if I'm typing whilst in the console port, and at the minute I am in the console port, I'm not Telnet or SSH'd in, this is as if I'm connecting to the console port. We've got, and I'm typing away and I get a pop-up, which we've seen pop-ups appear randomly when I close and open ports. Whatever I'm typing at that time will be copied and pasted to the next line. It's just quite good for usability and within that space, really. So I'll give you a quick example. So now I'm in. I'm just going to go quickly open up our fast Ethernet port we had closed earlier. We'll get a few prompts from that, and we're going to type in a few words, and we'll see our login synchronous take effect. With what I'm typing will be moved down to the next line after the prompt. So if I go int fa0/1, so I'm jumping from one interface to another. I don't need to go back up into global configuration mode. I can jump straight in there. And if I go no shut to say no shutdown, because that's what it's short for. And then what we're going to do is quickly type. Oh, it's too quick. I'm going to shut it. I can't. Because this is like an emulator, it's very quick. Normally it takes a little bit longer to respond, and I can't quite get my text to chop down, but login synchronous, that's what it does do. Next one, line VTY, so virtual teletype lines. So this is our IP connections in. So this is for our Telnet sessions and our SSH sessions that we're going to be setting up. This is for remote management, and this is fundamentally why we're setting an IP address on our device later. So line VTY 0 space 4, and I say 4 with a little bit of flexion in my voice because there are 15. If I do show run, we might see them at the bottom of the configuration here. Yeah, so we're only configuring 0 space 4, so there's actually 15 in total. 0, 15, so actually there's 16 in total. We're only going to be playing with 0 to 4, and we'll shut down the rest because there's going to be no configuration on them. So we'll leave that. So you'll only get 5 consecutive remote connections into this device. So I'm quite happy to have 5. If you need more, then configure more. So as a part of this, I'm going to set up Telnet, which is a very bad security procedure. But the reason why I'm putting it in is when we configure SSH on it, we'll see the removal of our Telnet. So transport input Telnet. I'm shuddering putting this in, but so we just set up we told it to accept Telnet sessions. We have various options. Going back with the question mark, so we've got none. We've got SH and Telnet, so we're going to use SSH after, which we'll be configuring. And yet again, we can say all, but for some reason I don't know why you would want to set both Telnet and SSH sessions, because SSH secure and also it's relatively easy to connect to a device using SSH. So login local again. That's saying use our local database of users, and I could add if I wanted to. I don't have to use a local username and password, which I can add in various users, and a little bit more advanced for this course would be to add in users of different visibility levels. So if you're a sysadmin, for example, and not maybe a third line support, you can only do show commands, and you can really granularize and relate it down. But to do that on a single switch is quite a lot of effort. That's where I suppose these skills that we're going through now are quite old and effective. It provides very good fundamentals, and that's what the aim of the course is really. But really the future and the currency of networks is software-defined networks, and you have a management plane and you set out your user levels based on your Active Directories and LDAP. So you don't need to create these users, and actually you shouldn't need to really do base configuration, but having a knowledge of these is going to be beneficial and provides you some networking knowledge as well, and things we covered off in the last video with regards to IP addressing and VLSM we're really going to bring out later on when we start adding to this network. Cool. So I'm not adding in the password. We're doing login local because of the local user we added in earlier, and also we're going to add in the extra one during the SH. Exec timeout 4 space 0 because it's 4 minutes 0 seconds. You can add, if I was to do the other way around with regards to notes, I'll be getting chopped out every 4 seconds. Login synchronous. So it does the same, it copies that, it's that usability while we're using this device. Then we're going to set our IP address. So the way we do that is interface, and it's not working because I'm in another sub interface. So int VLAN 1, and there's two streams of thoughts really. I'm using VLAN 1 as quite a simple basic build, but for security, because it's one of the most common VLANs used, and it is required as a part of various different Cisco protocols. So things like DDP, use it, Dynamic Trunking Protocol, DTP. But security says you never use VLAN 1, so you would ideally shut down this interface and do in VLAN 10. But doing this involves other, when we hit the root, it involves other technologies and other processes we've not touched on yet. So I'm going to stick with VLAN 1 for now, but then I'll show you how to use VLAN 10 and how that affects what we do on the router. So IP address 192.168.1.254, sticking with a really simple network here. And disadvantage of Cisco, it doesn't like slash notation, so you've got to type out the full IP address. And because we've already had traffic going to a few of the ports, we have to go no shut, because what happens is, as a security feature, it'll close the virtual interface. We can quickly check the status of our ports and our switch virtual interface. So if I do show IP into brief, or missing out a keyword there, do, which allows us to run commands from other modes as previously briefed. So do show IP int brief. We can see there I've opened up fast Ethernet 0/1 again, so it's not administratively down. We've got fast Ethernet 0/1 to 3 are up, so those are 3 clients. Going a bit further into it, we've got our gigs up, so that's the status is up and the protocol's up, so it will be receiving data. That's because one's connected to the router and the router hasn't been configured and it's naturally closed. Every port on it's closed. So we've got our VLAN 1 here with our IP address on, and actually that's pingable right now from the clients. So generally, just as a rule of thumb, is you only ever need one IP address per switch. And I've seen it before on many builds, and where builds start getting complicated with many IP addresses, the routing and actually the internal traffic of the LAN will get you to the IP address, and we'll be seeing that later. It's called inter-VLAN routing or route on a stick. So we'll be configuring that on the router later. We'll play with different VLANs. So we'll check what we've done so far. So do show run. We can see here we've got our LAN. I'm sort of twitching about this password here, so I'm going to take this out, and I'm going to use no just simply to take that out. I'm going to leave our enable secret in on our hash password. No IP domain lookup. We've got spanning tree port fast setup PVST per VLAN spanning tree. We're going to be configuring that later. We've got all our ports which are currently open and unconfigured. I'll just quickly fly through this. So we've got our 24 fast Ethernet 2 gig ports. We've got our IP address on VLAN 1. We've got our default gateway. We've got our console set up with login synchronous, login local, exec timeout 0 space 4 space 0, 4 minutes 0 seconds. We've got our line VTY set up and the additional one which isn't able. So as soon as we hit that 6th connection in, it will be dropped. Cool. with regards to show commands, I've sort of, and a lot of people agree, prefer to run the other show commands before show run, because if you're working with a large configuration and at the end of this configuring a switch will end up with a very large configuration, it can be quite daunting. But whereas if you run some of the smaller show commands and then you can verify against the show run or show start, then you can really dig in further. So when we get there, generally show run or show start will be the last show command I run. So show IP, do show IP into brief. I can see the status of my port, so my VLAN 1 is up, so it's saying the port is up and also the protocol's up, so it's receiving and getting data effectively. So we're good to go. So that's pretty much our base config. I'm going to start moving on to some of the layer 2 technologies now. So VLANs are something really to be aware of. We've got in a Cisco device, it's really clever. It's hardware driven other than software compared to routers. So it's only limited by the speed of the wire, and that's down to something called ASICs. That's something to do with basically it's the software imprinted onto a chip. And within a Cisco device, and the reason why I keep saying each port on a switch is its own collision domain, is because it makes decisions based on its MAC address, based on the destination MAC address. So it can decide which port it's going to send out. It's a smart switch. That's why it's called a switch. It can switch data, whereas a hub will send it out at all ports. So as part of this, we can see the MAC address table of this device. So normally on a Windows machine it would be ARP space -A, whereas this is show. Ooh. So some devices it's show CAN table. On this one it's show MAC address -table. And we can see here that it's not yet learned any MAC addresses for the devices. So what we'll do is we'll ping the switch and we'll get a MAC address log. So it'll say what VLAN it belongs to, MAC address type, and what port. So VLANs, what it allows to do is separation of data at layer 2. So basically, instead of having one MAC address table, one CAN table, content address mapping, we can have two. So if we've got VLAN 1 here and VLAN 10, it'll stop them talking to each other. So it won't let that data cross between, and even if it's in the same IP address range, then these PCs won't get to speak to each other, and it's really good for security and also minimizing traffic. So if I've got a broadcast message that I want to send down on all the Fs for the MAC address, it's not going to go out every port, it's not going to flood, it's only going to go out whatever ports are in that VLAN. So it breaks down the broadcast domain, and then that collision domain bit is basically a port by nature is duplex, so it can transmit and receive traffic at the same time. Right, let's carry on. So VLANs, as I said, separate traffic, and what we can do is create them, give them names and descriptions, and then put ports into them, as we can see on the left hand side just there. So what I'll do is I'm going to create VLAN 10 and VLAN 20. I'll have two clients in VLAN 20, and I have one in VLAN 10, and just prove that we can't talk. So if I go VLAN 10, wrong mode, and often it's just because we're getting back into it, often I'll be in the wrong mode. So VLAN 10, name, you can always tab it if you're unsure of the command, go halfway back in and just tab it. So name, LAN, VLAN 20, name, other LAN. Whether this is like separation of data, you could have HR or finance or whatever divisions people are in. So we've created our VLANs. Do show VLAN brief. So that's one of the commands. I'll just quickly add in here. Show VLANs. We've also got show VLAN brief. So I'll just quickly show you the difference. Show VLAN gives you a little bit more extensive information about, and if you're doing your exam for CCNA, for example, you need to know which VLAN numbers are already reserved, so you've got 1002 to 1005, which are system inbuilt ones. I think there used to be a token ring one as well. But if I do show VLAN brief, it's a bit of a neater layout, to be honest. And what we can see there is VLAN 1, all ports are sat in VLAN 1, and we've got VLAN 1020 created with names. And it's better to do it this way because I feel like it's more organised, really. So if I just put the ports into the VLANs now. So you have to go into the port and chuck it into the VLAN. So int FA 0/1 switch port access VLAN 10. So at the minute we're saying you're now in VLAN 10. I'm going to do something quite clever. I'm going to do fast Ethernet 2 and 3 together. So instead of going into each of the ports and saying you're in VLAN 20 and you're in VLAN 20, I can do them together. So it's using a range command. So int range, it's because I'm in the sub interface mode, FA 0/1 to 2. So you can see my prompts change with the range extension there. So I'm going to go switch port access VLAN 20 and do show VLAN brief. Cool. So we've got, that's not what I expected. Oh, I did. Right, hold on 2 seconds. We can always press up and correct what we've done. I need 2 and 3, don't I? 2 and 3. Switch port access VLAN 20. And we've seen the prompt say that VLAN has now changed state to down because all ports that are currently in use are outside of VLAN 1. And if I do int FA 0/1, just correcting what I've done for the design. Cool. Do show VLAN brief. There we go, that looks a bit better. So I've got fast Ethernet 1 to 3 are not in there, and they're quite sat happily within there. So there's 2 different MAC address tables really. That means the 2 clients 2 and 3 will be able to ping each other, and client 1 shouldn't be able to ping anything other than itself really, because also we've got the IP address on VLAN 1, so it won't be able to ping itself either. So the clients won't be able to speak to our switch virtual interface either, because that's sat on VLAN 1. Cool, so we've covered off VLANs and what the purpose is, separation of data at layer 2. We do that at layer 3 with regards to network. So if I've got maybe client 1 will be 1.0 network, and the other 2 can be 2.0, then that separation at layer 3 as well would provide another layer separation, also quite good for networking and security practices. Cool, so what I'm going to do is just quickly prove with regards to the communication on that. So I'm going to jump on client 1, and client 1 shouldn't be able to ping anything. Let's see if we can not break packet tracer, but let's see if we can start testing limits with regards to the MAC address table. So if I go ping 192.168.1.1, which is itself, so 1.2 shouldn't be able to ping because it's in a different VLAN. 1.3 shouldn't be able to ping because it's in a different VLAN. Was it 200? What was the IP address of VLAN 1? 100. So if I go 100, shouldn't be able to ping because that's in VLAN 1 and I'm sat in VLAN 10. Cool. Right. What I'm going to quickly do is just correct that, put them all into VLAN 1. Bad security, but easier for demonstration purposes. Cool. Right. So int range FA 0/1 to 3 switch port access VLAN 1. They should have saying that. Cool. Right. I'll go through more security stuff later with regards to what do we do with the rest of the ports to lock them down, secure them, and also to preempt some management tasks on them. And we've seen VLAN 1 has gone up because of the ports are now sat in there and they're active. Cool. Going to talk about trunk ports now. So what trunk ports are is a port which is connected to another network device. So whereas an access port, and we start getting into port types, so we use the command switch port access. An access is a port type. An access device is either a computer or laptop or a printer, for example. It's a user device, whereas a trunk port is connected to another network device. So what we've got set up here is our gig 0/1 on the switch is connected to the router. So we need to make that a trunk port. So what trunk ports do is they handle the network traffic, and they allow, by default, they allow all VLAN traffic to pass through them, and they will pass all VLAN traffic. We can minimize that down. I'm not going to show you within this section, but we can say do not allow these VLANs to pass. But also, ironically, between switches, each switch needs to have, even though it might not have the VLAN in a port, it needs to have the VLAN in its database, or show the VLAN brief in its VLAN status table to communicate and pass that VLAN traffic. So to even if it's passing it through on the trunk port to handle the traffic. So that's just a little quirk, maybe something you'll find out later in years to come. But if I go show trunk quickly. Trunk. That's not worked. Strange. Cool. Exit. Show. There isn't. I thought there was a show trunk command. Show. No. There we go. So I'll get to the command eventually. The command to show the interfaces which are trunks is show interface trunks. I'm just going to amend that on here. Show. So it's good that we're improving our notes as we go along. So what we want to do is make gig 0/1 our trunk port, and also I'll make 0/2 because we might be going to other devices later, other network devices. So if I go, I'm already in privilege user mode, so I can go straight to conf T and go int range gig 0/1 to 2, switch port mode trunk. So I'll quickly show you. There are different ones. I can do switch port mode access to say it's an access port, and what that does is it allows only access devices to access it. So computers, it will never, and by default they are dynamic. So what we've done is we've set up this switch with computers in, and it's dynamically gone. You're a computer. I'm going to make you an access port. I'm going to connect to you as a router. You're a trunk port, but also it's bad because later when we get onto, I think it's module 6 or lesson 6, we're playing with Kali. What we can do is change the Kali box connection to say I'm a trunk port, talk to me. And what Cisco will do by default, because it's really user friendly, is go, I'm going to start passing you all the VLAN traffic. So that means you're getting everything then as well. So that's why it's good to limit what VLANs have connection. So switch port mode trunk, and that does stir me on and let me think about should we make fast Ethernet 0/1 and to 3 switch port mode access, and yeah, 100%. So if I just jump back in here, you don't need the spaces. I quite often like spaces in there. Switch port mode access, and that's quite a big thing because we've defined it as access. So we've put these in a VLAN. So a part of that, I'm going to go switch port mode access. See, I'm always going to enhance the notes, and these are going to be available after the course as well. So cool. We can see the mode access, which is good. So I've made gig0/1 a trunk port, and what happens is it gets pulled out of that VLAN table now, so it won't appear because the trunk port acts and handles all VLAN traffic. It won't appear within show VLAN brief. So do show VLAN brief, and it will appear now just because I've said it. But as soon as that becomes active, and as soon as we open up the router's port and it starts talking to it, that will disappear from show VLAN brief. And that's where people get confused a lot, and people are like, hold on a minute, where's my port gone? And I'm like, it's a trunk port. So if it's a trunk port and it's in use and it's an active trunk port, then it's not going to show on VLAN brief. Cool. That's something to be aware of. So if you're taking notes, make sure you take a note of that, because I fell short of it several times. Right, cool. So we've spoken about VLANs and separating traffic at layer 2. We've prepped our gig0/1 up to the router as a trunk port. We're still very bad with security because we've got every port open, and we're going to get onto some really good security stuff late in a minute. But the biggest thing that I'm touching about is we're still using Telnet, and I'll just quickly prove this Telnet option. What I'll do is add in this username and password to the configuration and prove that I can Telnet in and prove our passwords into the switch. So if I go Control C to bin out of sub interface mode, go configuration mode, username, user, so bad, password. I never use these, honest. So especially password reuse is even worse. So as soon as we've got one, you've got them all basically. So I've got a username and password in there. If I do show run quickly, we can see this username and password sits at quite high at the top, and it's encrypted with the service password encryption. I'm just going to take out the enable password. So if I go no enable password, so I've taken it out, do show run. I'm just sort of cleaning up our configuration a little bit. So enable secret, no IP domain lookup, username privilege level 1, so that's reverse, so it's actually administrator, and encrypted password. Right, bro. So show IP int brief, double check our IP address. Oh, I've made that .254, and that's the planned IP address of the router in a minute. So if I just change that, so I'm doing this sort of ad hoc. I've got the diagram here, and I should have checked it before I put in that IP address. That's why planning a network is always necessary, especially with your IP address and making sure it's not overlapping. Cool. So no shuts just in case, and I'm going to Telnet from ping it and then Telnet from PC1. So chucking this to the side, ping 192.168.1.100. First one will fail, second one should be in. There we go, good. So what happens there is, depends how level of engineering you are. I fool people by saying that's because of the resistance on the wire and it causing the circuit to go through, but actually that's the ARP process. So the first ping fails whenever we try ping the switch, because A, the computer's learning the MAC address and so is the switch within its CAN table. So next one, Telnet. I wonder if this works from the... Yes, it does. So Telnet 192.168.1. I hate that we're using this at the minute. We will switch straight away as soon as we've proven this to SH. So we're in, and it's asking for that username that we've just put in. So user, password, which was encrypted, enable, and it's the same password as password, which is so bad security, but we're in. And then config. So now we can manage our switch remotely through the switch virtual interface and the VLAN IP address. Now is a good time to save it, because what the point is you don't want to start saving your device once you've applied the passwords and you've not tested them, because as soon as you come to it, then you have to redo your device, start from blank. That's something that is quite easy really to do. It just involves changing the configuration file. So I'm just going to quickly save this and probably remain within this window actually as well, just to see how us setting up SSH drops our Telnet session. So copy, run, start to save. Hit enter a few times, so saved. On a real device, this normally takes a little bit longer to go through. Cool. Right, so now we're going to set up our SSH config. Config's on the left. I'll talk you through it as we go through. We've already done the username, but enable conti, and then we've already done the username and password, so I don't need to do that again. IP domain name. Name LAN.local. Cool. For some reason that didn't want to tab, and might be because I'm telnetted in. But one of the things it uses to generate the crypto keys for SSH, it uses this domain name as a variant. So and it uses that to generate them. So we'll go through the rest of them. So crypto. Oh no, it is like in the tab. Crypto key generate, and we can only generate RSA keys here, but on real devices you can do a lot more. 1024 we'll go for. If I was to hit enter, then it would be 512, which is quite a low really. 1024 is a bit of a standard number. And as part of it, we're going to do, if I do show SSH, so at the minute we're running SSH version 1.99, as we can see here. That's got no security flaws in it, so it supports version 2, and you might as well always have the biggest and best. So I do IP SSH version 2, so we're now running 2. Which is good. Then what we have to do is go back into the line VTY, which is a virtual teletype line 0 to 4, and go transport input SSH. So we actually use it properly. So if I go line VTY, 0 space 4, transport input SSH, and I feel eyes in the back of my head while I'm typing this, because there's also transport output SSH. And anyone who knows anything about sort of CTFs and pivoting, with regards to a network device, it's really good to pivot from, and we can Telnet or SSH into other devices. So what we're saying is, if you're coming out, if you're in this device, and we can use this device to go from, make sure you're using SSH out, and it needs to, or we can actually go transport output none, which is even better security. So actually saying only allow connections in and don't allow connections from me out. So that's good. That's really good. Surprised at the minute our Telnet session hasn't dropped. So I'm just going to copy, run, start that. Do copy. So I'm going to come out and try re-telnet in. Come all the way out, and then try telnet again. Should say yep. Connection refused. Cool. So we can't access on Telnet. Terminal. I wonder if. Yeah, we can. So cool. SSH to 192.168.1.100. Username is user. Connect. Password is password. Enable password. I do want to show you something else actually before we move on to some of the advanced features. I'm going to go on to banners quickly, just because there's a few legal bits within that, so that I've not done. So it's cool, and then do show run. So just to quickly tell you what banners are, it's the same as a sort of SIOPS message or a warning message whenever you are about to go onto a system. So what we see here is our banners. There are different types. So just see what packet tracer supports. Banner ? So only supports messages of the day. There are different types. There's login. So you see that as soon as you start that connection. Message of the day is generally one that gives warnings about whether the system's going to be down later. So there's login, there's message of the day, and there are other types. Cool. And there's exec as well as one of them. So I'll do message of the day. Keep want to say match of the day, and then I'm just going to do ? So you can see here delimiting character. So if I was to put C, I've said the delimiting character within this command on the left is $, because it's not often one that's used. So as soon as you start typing $, anything after that becomes your banner, and we can do like little Gucci messages and little. So I'm just going to do like, I've just hit enter. Just going to do like, you are being watched. Hope not, but I know it's not in the center. It's going to be taking a few people's OCD here, but at least it's a banner. You can add in ASCII art. I've seen quite a few impressive ones before. Right, so we've done our banner, and obviously because it's being stored in RAM, and these all this configuration is being stored. So you want to keep your banners short. I've seen quite good pieces of art and ASCII art, but it's being stored, so you don't want too much, and it appears every time you log in. So I've seen like an entire airplane appear, but it's not effective for being logging on. So if I do show run now, we should be able to see our banner. I think generally it's near the bottom of the config, so we can see our message of the day banner here. If I save that, and then what I'm going to do is quickly exit out of that. Password is, and we can see our banner. Cool, you're being watched. Hearing. Enable. Cool. So it's good to have passwords on. It stops people getting into your system. Funnily enough, that's what they're there for. So we've covered banners. We've covered a little bit extra there. If I think of anything extra, we can always come back and add it in. But at least it's in the notes as well. So the big thing is the delimiting character needs to be at the start and at the end of the sort of the transmission and the text, really, to say BT and BT begin transmission. And cool. Right. Let's talk about some of the advanced features of layer 2 switching. We're sort of getting there with regards to switching. There's still a little bit more to talk about and configure, but we're not going to go through it all in too heavy. But we're gonna leave switches in a place where I like switches and where we're comfortable with them. We've configured the base config with additional security now with SSH, but it's good to know about some of the extras really and what goes on behind. I'm not going to talk about all the theory, especially with the next bit, is spanning tree protocol. It's big. There's videos out there really well describes spanning tree. I'm going to sort of fly through it, but it's something to be aware of. So I'll just quickly go into it now. So show spanning tree. So what spanning tree is it's a loop prevention mechanism for switches. And the way it works is, should I draw it out? Take a little minute. Yeah, draw it out. So spanning tree protocol. And what I said it's a loop prevention at layer 2, which within networks is massive, because as soon as you start bringing loop prevention or even loops, you can end up with something called a broadcast stall. And what would happen is, if I send out a broadcast there, then it sends out a broadcast, and all the way along it then keeps going round and round and round, and also expanding each time, because it goes, oh, I've got a broadcast, I'll send that. So each device would then send out that broadcast, that MAC address, whether it's an ARP request or a keep alive message. And so what happens here is we have what we call a fully meshed network. Have we? Yeah, more or less. That one's connected to that one. Every switch is connected to every switch, and what they do is they communicate with each other with messages called BPDU, so bridge data. I don't know. I used to bridge datagram protocol unit, something like that. Yeah, BPDUs. And these messages go out every few seconds, and what they do is they work out the lay of the land. They start working out who they're connected to, and then you work out the fastest way to speak on layer 2. So it's sort of like a mini routing protocol for layer 2, but not quite. There are various mechanisms we can change and affect. So what I can say is computer here. So we've got 4 switches, 2 computers, and what we want to do is communicate effectively. So we know that this one is directly connected to this one, really through a single hop, if we're talking networking, but just through a single link. And that's what we'll talk about. We won't mention hops, we'll say it's a link. So through a single link, we're connected, or we can take it the long way around. And often we find that's where our traffic will go, because of the way the way a spanning tree will shape the network. So we have, just imagine we turned everything on. So we have what's known as election take place, and one of the switches and it's worked out through a reverse way of how I would think of it. So basically it's worked out based on lowest MAC address of a port. And if it's lowest MAC address, generally within industry, anything with a very low MAC address is going to be newer, going to be older. Anything with a big MAC address like a Z is going to be newer, because it's later on in that pathway. So anything with the lowest MAC address is going to be elected as what they call the root bridge. So let's just say I'm the root, this switch. So that means all traffic must pass via him or via this switch, and we then start blocking other traffic. So it might say, okay, so you've got a direct connection to me, so that one's active. You've got a direct connection to me, that's active. And you've got direct connection to me, so that's active. So all traffic must come via that root bridge. But the case is now, it starts then blocking redundant ports. So it'll say, okay, so when you can't send traffic via that, because I can see you both and you can pass the traffic. You can't send traffic there, you can't send traffic there. You can't send traffic there, you can't send traffic there. So often within this sort of boundary, we can see the way it's going to send the data. So for this computer to access this one, it's going to send it through this other switch. Even though it's got a direct connection through, it will send it via the root bridge. And this is spanning tree. So it does loop prevention, but it also does traffic management. And we can also be clever about this. So this is just a very simple layout, and this is only one VLAN. So at the minute, let's say this red is VLAN 1. If I have a computer here, and this is quite often done within networks, and if this is VLAN 2, we can shape the way the traffic works. So we can actually say, well, at the minute, I would have to go this way to talk to this PC. But actually, what we can do is elect this as the root bridge. And what we can say is, well, if I'm the root bridge for VLAN 2, and I know I've just sort of blown a few minds, but it depends how far down the rabbit hole you want to go to. So what we can say is, I'm the root bridge for VLAN 2, and it is per VLAN. This is called per VLAN spanning tree, and by default we saw PVST turned on the running config. So what I'm going to say is, right, so for VLAN 2, you've got a connection to me, you've got a connection to me, you've got a connection to me, so block the rest. So forwarder, 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 blocker, 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 blocker. And we can really shape the way traffic works for per VLAN, and it takes quite a good architect. I suppose I was more at the top of the game with regards to networking probably 2 years ago now. This is recalling information and can bring to the forefront of my mind. So this organisation is called per VLAN spanning tree, and it's the way you can shape a network with shape a LAN at layer 2 to make it more effective. Okay, so often, and I'm going to throw together a very quick lab for spanning tree, just showing on packet trace with regards to 3 switches talking to each other. But what we see is one of the ports are blocked, but then we'll then change it so it's not. Okay, it's something that I really think we can. It's really good, and it brings enthusiasm for networking, I think, or brings you onto my enthusiasm for networking anyway. So I'll just quickly put together a lab, and then, so what we can see here is we've got 3 switches, and at the minute all their ports are yellow. Oh, you just seen one drop in. So this is where the election's taking place now, and we've got 2 links and 1 yellow on this switch here. So we've got a yellow on this switch. We've got 2 active ports. That yellow is a blocker, and we've got 2 coming here. I think this is the root bridge, or the switch in charge for VLAN 1, because these are all blank switches. If I just quickly show spanning tree, this bridge is the root. Look at that. So it's based on priority. I'm hesitant to go down sort of the rabbit hole of spanning tree too much, but so for VLAN 1 spanning tree, this is the root bridge. So this is based on MAC address, or the lowest MAC address. And I did say it's bad being based on the lowest MAC address, but also it's a good thing as well, because if you've had a switch there for 10 years and you are going to replace it, then that's part of the plan management change process. But if I bring in a new switch and plug it in and suddenly start connecting it up, then what could happen is I cause a re-election of spanning tree, and some packets may get dropped. Frames may be dropped, but basically that could cause re-election of the root bridge. But we've just seen it then. I'm just going to spend 30 more seconds on this, and I'm going to create the VLANs on each of the switches, and then we're going to make this yellow light disappear, because we're going to load balance our VLAN traffic to say, don't just use the one, actually use 2 of the switches as root bridges, but for different VLANs. So we're using VLAN 1 at the minute, and this one is the root bridge. So what I want to do is create VLAN 10 on each of these quickly, and then change the priority on this switch, so this yellow light goes out, but it will be going out because of the all the traffic for VLAN 10 will be going via that switch. Cool. This will take literally a few minutes, so you might as well hang on. I'm just going to conf t VLAN 10, and it's as simple as that. Exit, and it creates a VLAN there. So and as I'm doing this, if you want to think about which switch will be VLAN 10's root bridge. Ooh. Cool. So we've got VLAN 10 on each of them. We haven't got any ports in, and because of the way before I mentioned about trunk ports, they're automatically trunk ports because it's desirable dynamic. Switch port mode dynamic under each of the ports is automatic. So if I just exit from this, just exit again, and then cool, show spanning tree. So it's got VLAN 1. Okay. So just some calculation behind the scene. If I quickly go on to this bottom right hand switch here, they need to speak to each other effectively. So what I've done is made the ports that are on the left hand switch trunk ports. That's why you can see some of the prompts there. So if I go show VLAN brief, what mode you're in, Tom? Show VLAN brief. You can see there fast Ethernet are there. So everything's sat in VLAN 1. And if I go show spanning tree, we've got VLAN 10 now appeared. So it took a little bit of kicking in, and normally it takes a change within the network to cause a convergence. So a port opening or closing, for example, and that's what happened. I'll just quickly show spanning tree again, and we've got VLAN 10, and this bottom left one isn't the root bridge, but if I quickly jump on this left one, which was the root bridge for VLAN 1, and my suspicions is it's going to be the root bridge for VLAN 10 because it's based on the priority number. So I'm just going to quickly describe this priority number. So it's basically priority number is 32768. So 32768 is the priority number plus the VLAN number. So because that's 32769, so it's 32768 plus the VLAN number. So that is for VLAN 10, 32768 plus the VLAN number 10. That's why it's 77. So having different priorities and adding in the VLAN number allows it to do per VLAN spanning tree. So what I'm going to do is play around a little bit and make that top switch the root bridge for VLAN 10. So let's have a quick jump on here. Not really been on this one yet. So show spanning tree. So we can see it's got the same default value. And what we're going to work out is whether it's the highest wins or the lowest. And we'll go for 100. So if I go conft spanning tree VLAN 10 priority 100. Okay, so this is saying not allowed because this is the VLAN numbers. It's pretty much just saying you're only allowed these numbers. So if I choose 4096, is that lower? Yes, it is significantly. So if I do 4096, and then exit that, I might open and close a port as well. Conf T just to cause a election or a convergence is also another word. So int fa0/1 shut. No shut just to cause this re-election. If I show exit show spanning tree, Control C out, that's show spanning tree. Oh, so it's this is now the root bridge, and if I go back to the build behind, there should all be green lights, and there'll be green lights because of, even though some of the traffic isn't going one way with regards to VLAN 1, it's going around the other way for VLAN 10, which this is how you manage traffic at layer 2. Quite excited about it, really. But we changed it, so election of a root bridge for spanning trees based on a few different factors. Lowest port number or lowest MAC address. So it's based on obviously adding in that new device with a higher MAC address and it then causing a convergence. So they don't want to do that. That's why they said lowest MAC address by default. So if you're not managing your network at layer 2 and you do add a brand new switch in, it's not going to cause a convergence and not going to suddenly start causing a re-election or packets to drop. So I'm just going to close this off. And what we should see, it might take a little minute for it to drop in, but that's the root bridge for VLAN 1, that's root bridge for VLAN 2. This is the no IP domain lookup. See, I told you it sort of hangs out for a little bit. I am wondering why that yellow light is still there. It's slightly annoying. I might come back to investigate after, but we'll go. We've done enough on spanning tree anyway. Ish. We're going to touch on spanning tree again, but on a technology called PortFast, and PortFast is really good, really good, really good. Quite excited about this. So on physical kit, it's even better and sort of blows your mind because it negates the wait time. So what I'm going to do is configure fast Ethernet 0/1 on this switch as PortFast. And so what PortFast does, and here we go again, user cool. I was typing in a few default passwords and that were sort of muscle memory from a few years ago, but cool. So what PortFast does, it reduces the listening and the engagement stage of BPDUs for access ports. So I know that's like Jason is technical a dream code and a bit too deep, but basically it speeds up the way a port will respond to a computer being plugged in, and it's as long as it's only a user device or an access device or a computer being plugged in, it will go straight into communicating with it, and it won't go through the listening stages and the negotiation stages. Whereas normally, if you plug a device in, it takes a few seconds to exchange the MAC addresses and then goes from there. But whereas this is done by default. So what we'll do is configure fast Ethernet 0/1 with a PortFast. So conft int fa 0/1 switch port mode access, and that's a must. Spanning tree PortFast. Oh, yes. And what we'll see here is a warning. PortFast should only be enabled on ports connected to a single host. Connected hubs or other bridges to this interface when PortFast enabled can cause temporary bridge loops. So we're basically we're putting our ports at risk to say do not send or do not receive BPDUs, but we can also bring BPDU guard in. So what happens is if it does receive one, if we plug another computer in, it'll just lock straight away and it'll actually shut the port. We'll do that, and I'll add it into the notes. So spanning tree is a security mechanism basically. So also in addition, if I was bringing in a Kali box and I plugged plugged it straight into a Cisco device and I had PortFast enabled, it might still talk to it and spread all the VLAN traffic. But also, if I have BPDU guard and it starts pretending to send them out because it's one of the modes enabled on the Kali box, is the trunk port, then it will close straight away. So it's quite good. PortFast trunk, no. BPDU guard enable. Cool. So that's something that I'm just going to add to our commands here. Spanning, and actually I think it does get turned on by default anyway, but it's always good to put it in. I even tried to tab on the notepad document there. Brilliant. Bridge protocol data unit guard enable. Cool. So that will lock the port if another network device gets plugged in I'll have a go at that now actually, just to prove this to you. So what I'm going to do is disconnect. Disconnect this port. Delete that. Should I want to delete this item? Oh no. There we are. Cool. Right, and then I'm going to plug this into, from Fast Ethernet 1 into the switch down here, which hopefully will see that port. Yes. Right, so that port's gone red, and I think I've just caused a violation by, here we go, bridge data call error detection, gone into error disabled state. Yes, causing havoc on the network. So if I quit login, so show, is it a violation? Let me show. I know I can show it on interface, so show interface. Oh, not double show. Show interface. Right, so if there we go. So it's down, but got into error disabled because of that port, BPU port guard. I'm quite happy we got that. Show IP in brief. I'm just starting to interrogate the status of it. So actually, it just looks like it's been unplugged. It's not administratively down. It's just down. So whereas it's not getting data to it, bro. I'm going to bring that port up. So I'm going to take the port out of the switch, put it back into the client, and then shut it down and bring it up again. And then that port will be good. There's a couple of ways of doing it. I'll show you how to clear this error disabled state. Cool, right. Quite handy having that there. So if I just... oh, no. So if we just add our host in here, I've gone for Fast Ethernet 1 again, which is good. I want to try, I'll just do it on the side here. There's two ways of clearing this violation. So it's plugged back into the client, so it's an access port, so it should drop in on port fast, and it will, hopefully we should see it go green straight away with port fast. I don't know what type of simulation it's going to have, so it's red at the minute. So if I go clear, is it violation? I'm just gonna no. Okay. On normal Cisco devices, it's like clear violation, but obviously it's not working. But I'm also typing the word cheap. I'm gonna do the standard procedures to go shut, no shut on that port. So that's the other way of doing it. Conf T int fa0/1 shut, no shut, and it goes green straight away. That's cool. What I'm gonna do is take out the I'm gonna go shut no shut on Fast Ethernet 0/2 just to see how long it takes to negotiate, because we saw a port fast there, it turned green straight away, so it basically jumps a few of the stages from spanning tree and the negotiation to say what type of port it is. So if I go exit int fa0/2 shut, so it's gone red, no shut, so I'm expecting it to go yellow. Yes, that's yellow. I know you can't really see it there, but that's yellow. I'll just do it again. Go shut, so it's gone red. No shut, so that's yellow now. So that should go green in a minute once it's done its negotiation. It goes like listening, negotiating, and then on to communicating or connected. That'll take a little minute. So it's actually quite Packet Tracer is actually really good for testing its technologies now. I thought I'm testing the visuals to its max, I think, at the minute. Cool, we'll just wait for that to turn green. Cool, Fast Ethernet 0/2 is now green. I'm just going to do Fast Ethernet 0/1. Shut, just to show you again. So it's red, no shut. Right, this will turn straight green. Look, boom, port fast. Brilliant. I don't think people are getting as enthused as me about stuff like this, but there we go. So that's port fast. Next, we're moving on to, so that's spanning tree, which was good. Rapid spanning tree. I didn't say what that was, but basically, just cover it off because we're still talking about spanning tree with port fast. So what? If I go into the switch and do show run, we'll see what type of spanning tree is enabled. It's only quite, here we go. So we've got spanning tree mode, PVST, so per VLAN spanning tree. That was what I demonstrated at the bottom previous. But rapid spanning tree basically speeds up the selection process to literally a few seconds. So, and that looks like it's done in global configuration mode, not underneath the interface. So if I go conf T, exit, global configuration mode, spanning tree, enable, mode, rapid spanning tree, rapid per VLAN spanning tree. Cool. Do show run, and we've got here is rapid per VLAN spanning tree. So it's going to speed up that election process. It should be turned on by default naturally, but per VLAN spanning trees is and rapid is basically a Cisco proprietary technology, so that's why it's not enabled by default. It being per VLAN spanning tree and just spanning tree, and spanning tree is a vendor neutral technology. They all use it for loop prevention. But whereas if your Cisco device is only within Packet Tracer, there are other manufacturers, and this is something I didn't mean to say earlier, was a bit of a caveat, is that there are a lot of other vendors available, like Juniper and such like L3 produce devices, but I feel like the training given by Cisco and sort of kudos is given within the field, the certifications are quite good. So anyway, back to it. That's rapid spanning tree, and I'm just going to change this to mode. So these notes are based on my pre-thoughts. So show spanning tree, and we can check that with show run, and it's not applied to the interfaces either. So there we go. Right, bro. And did I do? I haven't done spanning tree VLAN 10 priority 4092, I think 4096. Cool. So that was changing the priority for the VLAN, so that enables sort of per VLAN spanning tree. Right. Show run to check. We've done port fast, Etherchannel. I'm going to quickly break from the video and set up the lab that we use for three switches for the Etherchannel lab, and then we're pretty much onto the home straight with regards to security and securing our devices a little bit more. So here we've got 3 switches, previous build with duplicate connections. Obviously they're straight through because it's going to like devices. That's something that you need to know. But at the minute, it's spanning trees doing a lot of loop prevention, and what we want to do is make these ports share and load balance the traffic between each switch. So what we're going to do is called Etherchannel, and there's different types. There's PAGP, LACP, and Etherchannel. PAGP is I'd say the most advanced, and that is also Cisco proprietary. I'm not like selling the Cisco dream, but LACP is the IE standard, so that is the vendor neutral, and Etherchannel is very basic, so it doesn't load balance, it just provides redundancy, whereas PAGP does redundancy for the fallback link, but also does provide load balancing by default, and there's different modes. We'll see that configuration here. It's really easy to set up. There are a few rules. Each connection type must be the same, and no more than 8 connections per Etherchannel. And you can see from the notes on the left, int range 0/1 to 4, channel group 1 mode desirable, so I'm setting up PAGP there. If I'm using LSAP, I say yes or no, but also the group channel number just before the word mode doesn't necessarily have to be the same. So if I've got multiple groups, you want to identify a cluster of ports together from that number, but it doesn't need to be the same number on the other side. So they don't actually communicate with that number. It's just a case of it identifies it locally. But you've got to make sure that your ports together are using that correct number. So we'll do that now. So within this left-hand switch, int range, I'm just going to double check what ports I'm using here. So I'm using 3 and 4 for this one, I think. No, I'm using 1 and 3, so that's good. I can still do the range command, but just use a comma. I'm just going to pick up the switch again. I've got a few windows open, I'm just going to, cool. Back to it, so I'm using 1 and 3 within this one for Etherchannel, PAGP. Int range, FA0/1, comma, FA0/3. So I know I'm configuring them both, and I can just comma it out. So using the range command intelligently. Channel, group, and I think I might be pushing Cisco Packet Tracer to its max. I've got a funny feeling it doesn't support. Oh no, it does support Etherchannel. Cool. So that's saying now that they're now off DTP. Because I've got them. I need to make them switch port mode trunk first. Just add that into the notes. Switch port mode trunk, because they're obviously Etherchannel's not going to be going to a access port. Switch port mode trunk. So they're all trunk, and then channel group 1 mode desirable. Brill. No error messages this time. Nice and clear. Do show IP int brief. We can see at the bottom. No, at the top, port channel 1 is down because the other side isn't set up yet. And once that port channel is up, that's the Ethernet, that's the Etherchannel now working. If I set up the other side quickly, so that's 1 and 3 again on the other side. Int range FA0/1 FA0/3 switch port mode access. Old habits, and then channel group. Actually, just to prove the point, I'm going to make it channel mode 2, channel 2, just to prove that it doesn't need to be the same. So that's gone up, and you can also see the port channel 2 is up. Do show IP int brief for this Etherchannel. And we're looking good, so that's up on that side, whereas we had 2 yellow here. That's probably going through negotiation at the minute. Or interestingly, that might be down because of the spanning tree. No, is just going through negotiations. So both sides of that are up. So that full Etherchannel is working. You may see them flash at the same time, passing the BPDUs. But I'm just going to double check here. So our port channel 1 is up. I'm going to do a few of these commands. So show Etherchannel summary. Do show Etherchannel summary. You can see we've got PAGP set out in Fast Ethernet 1 and Fast Ethernet 3. Bro. And obviously we can have LSCP set up, which has got hot standby, which is that only provides the redundancy really. LSCP, whereas PAGP supplies redundancy and load balancing by default. Bro. So that's Etherchannel. Port security. This is probably one of my favourites. Is locking ports down to specific MAC addresses, and there's a couple of different types. There's static and sticky or manual. So you can go manual and put it in where this command here, switch port security MAC address sticky MAC address. Where I put the word sticky is you put in the MAC address. You can do static, and whatever's logged in there at the time will then become a part of the config. Or you can use sticky and it's a little bit more dynamic. So just going through the commands there, switch port mode access, because it's only going to be used on access ports on user devices. Switch port security max 2, so that's saying maximum 2 MAC addresses logged, and that's down to personal preference. I like 2 because often when I'm doing these demos on live kits, I'm running a VM, and for that VM, that will then have its own MAC address. So if I'm running a VM with a physical machine, that will have 2 MAC addresses. So to save the ports being locked out, you can have 2. If you're just running an office-based client and it's just 1, then you can keep it down to 1. But often you'll piggyback your phone, your VoIP telephone through your client, so you'll need to have 2. MAC address sticky, so that'll log the MAC addresses, and then turning it on with switch ports -security. Cool, we'll do that now. On the original build, on Fast Ethernet 1 to 3. This is why I set up very simple passwords. But this is at the minute as a bit of forgiveness. So this is not a production environment. This is obviously a training, but it's still not been. We're still configuring it. So pre-live day, then making sure that those passwords are then put with an adequate level of security and complexity. So int range FA0/123 switch port mode access switch port -security. If I hit enter there, it turns it on. I don't want to turn it on yet, because if I had VMs running, which from the early lesson I've just closed them down, I would have had 3 MAC addresses. So I'll close them down, so now I can only have 2. Obviously, if that was rootkit, it wouldn't matter. So switch port security, I can just press up and continue. MAC address, MAC -address, and I'm just going to go question mark here, so I can go the manual route with the 48-bit MAC address, split down by full stops, not colons. So that's a Ciscoism, and I can just type the word sticky. So what that's going to do is log the MAC addresses within the running config, and I'm just going to show you quickly. So if I do show run underneath Fast Ethernet 0/1, I've got my port fast stuff here, but I've not turned on port security yet, but I've got sticky there, and underneath each of these we'll start seeing the MAC addresses being logged. So if I just press Q at that and then turn it on, switch port -security to turn it on, and it's often something people forget to do is just turn it on. Do show run quickly, and nothing's been logged yet because there's no traffic coming from the clients. But if I just go onto the clients and ping the switch and then cause the ARP process to go past, First one drops. In with a second. Cool, same as before. And I'm just going to check the MAC address. Ifconfig. So the last physical address, 1alpha32, 1A32. Let's just bring out of that and go back on here. 1A32. Control C, run, show run again. 1A32, 1A32 being logged there. So sticky, as devices get plugged in, they start getting logged as well. So maximum 2. So if I try put, what I'm going to do is take this client away and put, what I can do is put client 2 and 3 into it and it'll lock as part of port security. Cool. And what might be a good little demo that actually, I'll get that done. So if I exit, so we've got maximum 2 set up on port 1. If I do show port -security, so we can see port security set up on them all. So we've gone show port security. If I go show port security, so what I want to do is we've got one MAC address logged currently on FA0/1 and 0 violations. What we want to do is see that a violation come in on 1 and we've got a default action shut down. There's different warnings we can have and different alerts. So you can say port security violation alerts and it will send an SNMP message up to us like a syslog server or login server to say that a violation has occurred. And yeah, so that's quite good from a user perspective or an administrator or NOC perspective. What I'll do is actually prove this port security quickly. So I'll just delete this. Nope. Delete that, delete that, delete that. So I'm going to connect this client to this client. So I've just logged in. I've just put that one in to fast Ethernet 0/1. So I'm going to ping this to call some traffic, and it logged to log the second MAC address. So ping 192.168.1.100 drops the first one in with the second. Because the ARP process. Cool, right. We can delete this one and connect this one, and it should also, in addition with port fast, it should go red straight away. So that's been blocked out. So it's really good to protect your access layer really of switches against rogue devices being plugged in. So I'm just going to go into this device, and what I'm going to do is open up the port, but it's still not going to be in the list, so it instantly go closed again. Just as a little bit of a networking funny, because people end up in this scenario if you haven't reset your MAC addresses on it, and it's quite easy to do that. We'll show you how. So I'll go shut no shut to clear the port security, and it calls another violation, and then we'll clear the MAC addresses on the sticky bit to then allow this PC in. So show port -security. So we can see one violation here. It's maxed out on its MAC addresses, and the additional one from the third client picked in. So show run quickly. You should have, I'm going to fast Ethernet the 2 MAC addresses, which is good. And if I go shut, no shut, and green for a second, then red, but it's just triggered out again, even though administratively wise we're thinking, well, we want to allow that. So we're not allowing it. It's still, even though it's connected and we've opened it up, it's still kicked in administratively down. So if I do show port security again, do show port -security, we've still got a violation. So what I want to do is clear the port security, and this is where the all. So it's going to clear all the MAC addresses, and then I can go show run, and the MAC addresses here under FA0/1 would have disappeared, which is good. and so I've just reset the port, and it goes straight to green because of the port fast, but also it's now usable. Do show run, and the MAC address, one MAC address logged at 2. Brilliant. And it's there. So that's basically port security. I'm going to quickly configure this back how it should be. Fast Ethernet 1, which is good. Fast Ethernet 2, and those will, while I'm reconnecting it in, those will be logging the MAC addresses as well. So you can see what we do with our open ports at the minute, and I'm gonna add to this list on the side because it's been going through a few bits. We want to expand this and add to our standard configuration for what we use for open ports and closed ports. So we've got for security reasons and also management wise, for an open port we want to have in FA0/10. I'm just going to add in clear port security R under this one. So that clears the MAC addresses under the running config. Cool. So for an open port, we want to have switch port mode access, switch port access VLAN, a different VLAN to VLAN 1. We've got access in there twice, we don't need that twice. Switch port security maximum 2, MAC address sticky, and port security. And also we want to have spanning tree port fast on there as well for an access device. So not only do you want it to be secure, you want it to be fast and usable straight away. So we want to go spanning tree port fast, spanning tree BPDU GUARD enable, and I'm going to try click this in, see if this works. Copy. So this is an old like quick way of getting in commands very quickly into RealKit as well. Let's see if this works. Boop. Yeah. Up. And the advantage and disadvantages with this is making sure that your commands are correct. And spanning tree BPDU guard GUARD. I wonder what's wrong with that command. There's no hyphen. Cool. So if you are going to get gobby, I suppose, and start copy and pasting commands, and you've got to make sure they're right. So that I've just done that on Fast Ethernet 0/10. So do show run. Let's have a quick look at the config on 10. So we're VLAN access port security max 2 sticky and BPDU guard. That's really good. So that would be on a used port. What we want to do for closed ports is very similar. One big thing is we want to define it as an access port, because an access port only acts in one VLAN, whereas if I leave it as automatic, so even if I just want to shut a port, so if I say now I'm not going to use Fast Ethernet 0/16, int 16 shut, and for most people that's good enough. Just shutting the port is good enough, and you want to plug it in, and like a client wouldn't be able to access that port. But what happens if the case that was to fail? You want to manage your devices so they're sort of future-proofed as well as secure. So hence some of this configuration. Switch port mode access, we're defining it as an access port rather than automatic. So if that shut was to fail, we're still saying it's an access port. So it only act in that VLAN it's in. It wouldn't be able to handle all the VLAN traffic. So if a Kali box come along acting as a trunk port, wouldn't then suddenly be able to start sucking all that traffic in and start monitoring, start doing a bit of the man in the middle. Also, VLAN 666, doesn't necessarily have to be that number, but I'm putting it into a dump VLAN, and that to me stands out quite well. You'd have to predefine that, and we will do that as part of this now quickly. And I'm going to clean up this switch build just to make it a good standard really. Putting port security on it does protect the port against future mitigations really. So if you've got quite a secure network, you've closed all unused ports and you like to manage it properly, and it would take a lot of work to then reactivate a port, because you'd have to reactivate it, you'd have to go no shut and then put it into the correct VLAN depending on what the user wants. But you've already protected it, and you've done, in the long term, you're doing work now to save yourself like misdemeanors after. Whereas if you didn't set up port security, once that port's enabled, you might forget about that, or some junior might come along and set that up. At least it's already set up there, ready to go. So the work now is saving long-term work, really. It's about setting yourself up right initially. Cool. So, and also we want to have port fast on there as well. Cool. So the big things are shutdown, mode access, and in a dump VLAN. So it's not even getting broadcast messages through the CAN table. So I'm just going to paste that in. I'm going to make it 16. I'm going to paste that into BPDU card enable. Copy. And I'm just going to paste this into the config just to set up Fast Ethernet 16 as a very highly administered port, but short and secure. So do show run port 16. So we can see it's shut down there. That's the difference between that and 10. It's shut down. It's in this VLAN 666, and it's got a very similar setup. I'm just going to show you one line it did when we created. So when we said VLAN 666, access VLAN does not exist. Now creating. So there's two ways of doing VLANs really from what we spoke earlier. I'm just going to quickly recover that. So one way was to create the VLAN. So if I go within global configuration mode, VLAN 222 name dump. So that's a way of creating it. Do show VLAN brief won't appear. Well, it has appeared. Sometimes it doesn't appear until you exit out of it. So it's appeared there. But also, we've created this VLAN 666 on the fly by chucking a port straight into it, but it doesn't name it. And actually, I prefer having a bit of a name to it, and it shows a bit more organisation. So if I go, I can now go back into VLAN 666 and name it a dump. VLAN 666 name dump, and we've already got a dump, so I'll name it dump 2. Do show VLAN brief. There we go, we've named it. So it's personal preference really, but I prefer to create VLANs first and then create the VLANs, name them, put the ports in, because then you don't end up with any prompts you don't know, and often you'll end up with sort of logs you don't need and things like that. It just prevents any confusion. Cool. So you want to create what VLANs you want first, then put ports in. So we've got, those are the closed ports. I'm just going to quickly clean up our build and make it secure with regards to that switch. So we've already got SSH on it. We've already got a few VLANs, but I want to really just lock everything down. I'm not going to change the passwords yet, but I'm going to take control of the ports that I've got. I've got gig 0/1 is going to router, so I'm going to leave that as a trunk port. I've got gig 0/2, which is going to be an unused trunk port because I might want to attach a switch to that later. So I'm going to have that switch port mode trunk and shut down, which, yeah, it's a little bit dangerous, but because I know I'm going to be using it as trunk related, it's a gig port. And then I'm going to have fast Ethernet 0/1 to 3 set up as an in-use port, and then I'm going to have 4 to 24 lockdown. It's just a bit of a clean-up mission, really, and make it nice before we move on. So it's just using the range commands and pasting what we've done in. So int gig 0/1 switch port mode trunk, int gig 0/. 2 shut switch port mode trunk. That's the spare gig port. So now we've got 3 to 24 to shut, 4 to 20 shut down. So int range fa0/4 to 24, and might as well be a little bit lazy, and we've worked hard with our notes and might as well use it. Cool. So that's given us the warnings about not allowing it to be connected, and we've already made it an access port anyway. Int range 0/4. And I'm going to make them still VLAN 1. I know it's naughty, but it's just for this bit. No. I'll actually make it a VLAN 10. We'll do things properly. So do show run. Things have got a little bit bigger. So password's good, privilege, SH version 2, no IP domain lookup, as we saw activate on the earlier. Spanning tree, rapid per VLAN spanning tree. We've got FA0/1 in VLAN 10, 2 in 10 and 3 in 10, with port script set up with port fast enabled and their access ports. So that's good. We've got MAC addresses logged on 0/1 but not 2 and 3 yet because there's no data going through, but they'll come through eventually. And then we've got 4 to 24 shut as access ports in VLAN 666, which is a dump. Then quickly fly through to the gig ports. Gig 0/1 is in use as a trunk, and 0/2 is shut down but as a trunk. Cool. We've got interface VLAN 1 as with the IP address we want, so we'll change that to VLAN 10. So we're going to take up the VLAN 1 IP address and change that. We don't need to change our default gateway because that will just balance out through where we are. And that's pretty much it. There's a few little bits we can add on, as in NTP for logging, and we can also there's various other security things which we'll talk about in a minute. But I'm just going to change the VLAN number into VLAN 1, no IP address, shut. Cool. And int VLAN 10, because that's the one that we're using. IP address 192.168.1.100 and no shut. Cool. Do show IP int brief. Let's have a look how that looks. So we've got up and administratively down on the rest. Gig 0/1 is down, but that's because the router is not being configured yet. And we've got VLAN 1 is administratively down, and Gig 02 and VLAN 10 is up and with the IP address. Just going to prove connectivity through again, and then talk about the other security features. And save this. Copy, run, start to save, enter 3 times, and we're good. So we've got up here, prove connectivity through from this one. Ping 192.168.1.100. So that's pinging from switch port access VLAN 10 to int VLAN 10. So that the first one drops because of the ARP process, and then in with a second and third. Brilliant. So that's now working. We're on this switch, and from that ping, additionally, we should see the MAC address appear in show run. I'm just going to prove that. Show run. Cool. And we've got the MAC address appear from there. And it wouldn't have locked down because we've got max 2. Brilliant. Right. So we've talked about open and closed ports. Next one, quickly, we're going to talk about span ports. A span port is switch port analyzed network, I think. It's basically I've got a diagram of it which I can show post the switch config. It's basically if you have a network analyzer, an IPS or an IP intrusion prevention system, or an intrusion detection system. You can use this to move data or replicate data. It takes basically a copy of whatever VLAN traffic's happening and pushes it out, fast Ethernet 0/19 in this case, to allow monitoring to happen. So it's used for like Wireshark, for example, or IPSs or IDSs, and it's really quite good to have, really good for security. So if you're setting up a NOC, it's something which is going to be mandatory really. So property int FA 0/19, and I'm just going to go no shut on that. So we've got configuration on port 19. I want to clear the configuration on port 19 quickly. There is a very quick way of doing this. Clear. Configuration, clear. IP. No. I don't think this is going to work. No. It does on real Cisco devices. This does. There's often a few little commands, and I've been typically impressed with Packet Tracer at the minute about what we can do. But I'm just going to move fast Ethernet 0/19 into VLAN 1 because it's got to sit within that VLAN to be able to monitor traffic. So int FA 0/19 switch port. I don't think you can set up a span port on spanning tree. No, you can. You can. It's accepted a do show run. It just didn't like the tab. Do show run. Go through to 19 and scroll up a little bit. So on 19 we've got no. You can't see it's in. No, it's so you can't. Those are the correct commands for a span port. Do show span. Spanning tree. Okay. It doesn't like span ports on Packet Tracer, but anyway, it's in the notes. I'm going to talk you through the next bit. So DHCP snooping works in conjunction with something called DIA, dynamic dynamic ARP DAI. Cool. So DHCP snooping works directly with DIA, dynamic ARP inspection, and what it does, it prevents any other port then allowing DHCP requests to go through it and act as a DHCP server. So once you've said, for example, a lot of the time either you'll use a router as a DHCP server or a domain controller providing DHCP services through Active Directories, you'll say that's connected to port 4, for example. What you'll do is you'll limit that only port to accept and transmit DHCP DORA processes. So it's discover, offer, DORA, request and acknowledge. So if I just quickly set it up on fast Ethernet 0/19, interface FA 0/19. So what we're saying here is this is going to be the DHCP port for whatever VLAN. So IP DHCP. Oh, it allows it. Snoop. Trust. And as soon as we hit this, That's it turned on. So we're now saying trust this port as a DHCP. So as soon as any other port then tries to start offering DHCP addresses, it will shut down and won't allow it. So once your network's configured, make sure you're not going to start adding any random DHCP devices in, for example routers, which often within a sort of people trying to create their own, is it called red IT, I think, where or grey IT space, where people are bringing in their own Wi-Fi device and things like that and plugging it in, and then it starts offering IP addresses out. This will stop it, in addition to port security, access ports and things like that. Cool. So that's DHCP snooping. I'll just quickly show IP DHCP snooping. So it's turned on and we're unlimited, so it's, all the defaults have been accepted. We can stay specifically within what VLAN and choose additional options, but that's basically saying Fast Ethernet 0/19 is our DHCP server port. CDP neighbors is really interesting. If I do it not on this one, but on this build we've got, so hit enter a few times, show CDP neighbors detail. So what CDP neighbors is basically Cisco Discovery Protocol. There's Cisco proprietary, LACP, no, Link LLDP, Link Local Discovery Protocol is the open source version, and we can enable that on ports as well. It's really good for setting up and troubleshooting, but really bad for security, because as soon as you're on the network, and if you know it's going to be Cisco, then you can do, and it's not something that does get turned off a lot because administrators aren't aware of it, but it's something that we can use as an adversary, as a bit of a vector for awareness and pattern of life and building out what we can see, and then you can work your way through and pivot your way through a network. So if I just run it again, show CDP neighbors detail, there's no IP addresses set, but they're all called switch as well. But what we see here is the ports are full duplex, and we're talking to other switches on whatever port, and also we can see here we're talking through it on Etherchannel as well. So we can already see what's being advertised and how much Cisco is selling to each of the devices. If I do show CDP neighbors, it might be a bit simpler. So it tells you what device it's speaking to. So if we had switch 2, for example, it'd say here, it says through what device, what speed, and what platform it is. So it's a 2960 Cisco switch. Really good. To turn it off, as we want, it's in global configuration mode. CDP neighbor. Oh. CDP. That's not letting me disable it. So that's not allowing me to disable it. So what we'll do is we can enable it by CDP enable. Ah, I know. No CDP enable. Run. No, different operating systems, different iOS devices, I think. So to turn it off, globally, no CDP run. On other devices, I'm going to leave this little note in here. It might be CDP disable or no CDP enable. Okay, so it depending on what iOS it is. Cool. So that's turned it off. We can turn on LLDP run, I guess, because it's a bit of a funny Cisco operating system. So that's LLDP, Link Local Discovery Protocol, is the open source vendor, the vendor neutral version of CDP. Show LLDP. Oh, it doesn't look as pretty as CDP. I'll add that in there as well. So cool. And then to take it off, no LLDP run, which I'll just take it off now. So cool. It's once you have the formation of commands, you can sort of work your way through. So we're going to talk about these: root guard, BPDU guard, and loop guard. Loop guard, starting from the bottom, loop guard prevents loops and preempts loops if one may happen. It's quite a good configuration. This is a little bit more advanced Cisco knowledge. BPDU guard, we've done that, and I'm just going to take the space out of that because the command is BPDU guard enable, and that was if it detects a BPDU, which is basically a layer 2 spanning tree hello message, it'll close and it'll violate to shut down straight away. Root guard basically prevents the root changing. So even if a reconvergence happens below it, the root will stay the same. So he will say, well, that switch will say, I am the root, I'm not changing, and it prevents a convergence. If you're happy with your network setup, then you can use root guard. Let me show the command of that. Conf T off the top of my head, I did know it. Spanning tree, root, is it root guard enable? Root guard root primary. So I've made this switch to root primary, but it's not guarding it. I'm not too sure what the command is for that. Cool. We've spoken about per VLAN spanning tree, but private VLANs is a whole nother layer. It's a VLAN within a VLAN. Segments the information a little bit further. IP source guard prevents the IP addresses changing, so it starts logging IP addresses. You've got dynamic ARP, not analysis, it's inspection. DIA, we've already mentioned that. So it acknowledges, it starts reviewing the source MAC address of ARP requests and DHCP requests and logs that. And as soon as that address changes, it will shut the port down. So it goes hand in hand with DHCP snooping. Control plane policing. So the control plane is basically the data it works with. So when I ping, it's a Cisco's really, and something to be aware of. So a Cisco device is split up into a few different planes, they're called. So when we SSH into a switch, that's called the management plane. When we are working with like information going in, that's called the data plane. But when the data is internal to the device, it's called the control plane. So what happens is the way it manages the data itself. So to stop the device being overwhelmed, we can set like a QoS limit. We can set a, which is quality of service. We can set a drop limit on certain amounts of data coming in. So if not only for the switches but also the routers. So to control the amount of limit coming in, the amount of data coming in and it processing at once, we can set a QoS and just say drop. It's in the form of an ACL, and it stops the switch or router being overwhelmed and also prevents a DOS attack from happening. VTP, virtual trunking protocol, shouldn't be called virtual trunking protocol, should be called virtual VLAN promulgation or advertisement protocol. It exists, it's good for security and management, but it's really bad. And what I'm going to do is quickly show you, I think, in a demo before we move on to routers. It's something that it may work within Packet Tracer, but we'll have a look. So Packet Tracer does do VTP quite well, but doesn't do the disadvantage of VTP, which is like VLAN poisoning, in which bringing in a rogue switch with lots of different VLANs on doesn't poison or chop off some of the VLANs that already exist. So I can't do the demonstration, which would normally be done on real kit and does work quite well. So we'll move on from there. So we sort of finished with regards to the technologies within switches and layer 2 really, with regards to security practices and the layer 2 technologies. Just before we move on to routers, I'm going to do a quick fly through of the slides for switches. There's only a few, just to give a picture about what we've worked with, and then we'll move on to the router and configuration on that, and then that's us really allowed to ping across to that other network just up here. So we've worked on the switch, we're now going to work on the router, quickly do a base config on that, employ the other technologies that are available, and then allow the PCs then to connect through to the web server. So we'll have a quick look at the PowerPoint. So we've spoken about the modes, the base config and verifying commands. We've gone through loads of show commands. We've spoken about employment of Telnet versus SSH, and on the left you can see a Telnet session which shows the password on a Wireshark capture, and on the right you can see the encryption of the SSH and the RSA keys that it exchanges. The only thing that you do see with the SSH is the first line of the capture will say what version of SSH it is. That's the only weakness really that it's got, because it may say SSH version 1.9, which is open to an exploitation. But we can see on the left, Telnet open there and really quite bad. We've spoken about layer 2 technologies, switching, VLANs, port trunks, trunk ports, spanning tree protocol and Ethernet and Etherchannel and PAGP and LSAP and Ethernet itself. We've spoken about port security and stopping MAC addresses just being logged in randomly and people attaching whatever they want to a network, and the default action based on port security was shut down. We spoke about span ports and a network analyzer, and whether it's a PCAP capturing or intrusion prevention, intrusion detection system being pulled off that to allow that traffic to be analysed. Next, we're going to be going on to layer 3 technologies. So we're going to talk about quickly the base config. We'll go to into VLAN routing. So we've already touched on VLANs. So what we're going to do is allow these VLANs to talk to each other, and then we'll talk about further layer 3 technologies. Looking forward to it.